Hey everyone, Nitesh this side. Hope you are doing good. So let's start with the question. So the question is combination sum 3. Okay. So there are questions related to combination sum and combination 2. So you can check that out also. So first we will check combination sum 3. So what is this? We like find all valid combination of k numbers that sum up to n. Okay. So you're given a k and you're given a n. So you have to find out k numbers whose sum is equal to n. So such that the following conditions are true. Only number 1 through 9 are used, okay, and you can't use the same number again. So each number is used at most once. So what you have to return? You have to return a list of all possible valid combination. The list must not contain the same combination twice. Okay, so the same element or the same, you can say same sublist cannot be there, and the combination may return in any order. There is no need to maintain any sequence. Okay, so let's understand with an example. Okay, so we have given this example k equal to 3 and our n is equal to 7. So what's the condition? You can take only number from 1 to 9 and you can choose at most 1. Okay, only single element can be there. You can't take 1 at like 3 times if k is equal to. So you have k equal to 3. So that means you have 3 position 1, 2, 3. So and you need the sum of 3 of them is equal to 7. Okay. So let's say we'll take 1 here. Okay. And if we take 1, we can't take the same number again. So let's assume we'll take 2 here. Okay. So after that, we can't take 1 and 2 in this position. So we have option of either we can choose from 3 to 9. So let's say we choose 3. Okay. So if we do some 3 plus 2 plus 1 is 6. So this is not a good option. So we will remove this. We'll choose the next option. So we have 4. Okay. So if we can see 1 plus 2 plus 4 is 7. So this is one possible sublist we can take. Okay. Let's see whether we can take any other. Okay. So after 4, if we do the sum, like all will be greater than 7. So let's change here. Okay. So here we have position of 2 to 9. Okay. So let's assume we will make it as 3. Okay. So 1 plus 3. And now let's assume we will put 2 here. So 1 plus 3 plus 2 is again 6. Okay. And 3 we can't take because 3 is already taken. So, and if we do 4, so it will become 8. So we only have this one possible output for this case. Okay. So let's see with another example. So we have again k equal to 3. So that means we have 3 position 1, 2, 3, and we need a sum as 9. Here, what we have option, either we can choose 1 to 9. Okay. So like at every place we have the 1 to 9 option, but if we choose one number from here, so we can't choose the same number again at this position. So let's say we'll take 1. Here we will take 2, and we can't take 3. If we take 3, it will become 6. If we take 4, it will become 7. If we will take 5, it will become 8. Let's say we'll take 6. So 1 plus 2 plus 6 is 9. So this is the one possible output. And there are other option also, so you can see with an example. So 1 plus 3 plus 5 is also one option. 2 plus 3 plus 4 is equal to 9. Okay. And if we see the example 3, we have k equal to 4. Okay, but we need the sum as sum as 1. So let's say we'll take 1, but if we take any number which is not 1, it will give the sum greater than 1. So there is no valid sublist, so we just return the empty list. Okay. So I hope the question is clear to you. Let's see how we can okay. So let's understand with the example 2. So we have k equal to 3 and we have n equal to 9. So we have 3 position 1, 2, 3. So what we will do, we will pick any number at a time and we'll go further. Okay. So let's say we'll take 1 here. Now if we take 1 here, we can't take 1 at the next position. So let's assume we'll take 2. Okay. So now 2 will take, and now we can't take 1 and 2. So let's say we'll take 3. So if we do the sum of them, so 3 plus 2 plus 1 is 6, which is not equal to 9. Okay. So what we will do, we will backtrack from that position. Okay, so we will change at this position. So we'll remove this and we will just push 1 2 and we'll put 4. Okay, now if we do the sum, it will become 7. Similarly, it is also not equal to 9. After this, we again backtrack. We backtrack basically means we will remove the last element that is inserted, because this is not giving our output and our k is also filled. If let's say we have k equal to 4, so then we'll go further, but here we just, like, our k is also full and our sum is also not become uh, 9. That means we have to roll back again. It's not become, so we will roll back and we'll put 5 here, so it will be 8. Again this is not equal to, so we'll again roll back and we got 1 2 6, say, which is equal to 9, equal to 9. Okay, so like this is the one combination we got. After this, if we increase our basically this value, if we put 7, this sum will become like greater than the given sum. So what we will do, we will not go further than this, we'll just return at this position. Okay, so it means now you have to backtrack this position. This you have done by 2, you create the combination, now you have to backtrack. Okay, so how will you do? So you will make this 3, like this will remain at the same position, and you will again do the position for this. So you can't take 1 here, you can't take, you will take, you can take 2 here, so we'll take 2, and 3 plus 2 plus 1 is 6. Okay, but this is not equal to 9, so we'll roll back, this, we'll put 3, we can't put 3 here, we'll put 4. So 4 plus 3 is 7, 7 plus 1 is 8, which is also not 9, so we'll change. Okay, we again change it, we'll make 5. Okay, so 1 plus 3 plus 5 is 9, and which is equal to 9. So we got our output. This is the second possible. Okay, after this, let's say we'll increase. Okay, if we increase, this will become 6. 1 plus 3 plus 6 is 10. So we don't need to move further when we get our possible output. Okay, so now you again roll back at this position. You will come at this position, you have 1, now you will put 4. Okay, similarly, and now you will put 2 here. So by this you will change every time, like you will go through with this, then again you roll back and you will change this position. Similarly, when you like reach to 9, after this you like try all the combination, then you come back at this position and you make it as 2, and you make all the combinations. So as you can see, this is the one more combination, 2 plus 3 plus 4. This can be also a valid option. Okay, so it's just a normal backtracking question. So what we have to do, every time we will take a element, we will insert it and we'll solve the question. If we were not able to solve, we will just backtrack from that point. Okay, so it will be more clear if we write the code for. Okay, so let's see, let's create a global list of lists, so we don't have to pass in every function. Okay, list equal to new array list, and we'll just return that list. Okay, let's call the solve function, and let me give the k, and let me give the n also, and let's create a sublist also. Okay, so let's create a integer sublist equal to new array list. Okay, so now we'll solve our function. So void solve int k, int n, and list of integer sublist. Okay, so this will be our base case in recursion, and we will have a recursive tree. Okay, so what we will do, we only have option from 1 to 9, so we'll loop over it. So for we have this option only, for int I equal to 1 to I will go to 9 and I plus plus. Okay, so what we have to do, either we will take it, so first step we will take it, so sublist dot add will take I, and we'll call our recursion function. So what we will do, so let's say we will take this, so if we take this, we will decrement our k. Okay, so we'll do k minus 1, and we'll also reduce our sum, we'll do n minus I, and we'll pass this sublist. Okay, now the backtracking step. So what we need to do, let's say after doing this, you will be able to solve or you will not able to solve, you have to traverse all the path or all the direction. So you will remove it. Now you will, let's assume you will take one here. So for the next time you will take two at that position. So we'll remove the last element that we just inserted. Size minus one. Okay, so I think we have done with the recursive tree. So let's write the base case. So what will be our base case? So how we can check whether we got the valid input? So valid input is only be possible when you're let me explain you here. So as you can see, this is a valid input because 1 plus 2 plus 4 is equal to 7. So that means our k is full and their sum is 7. So if I do the vice versa, that means if I decrement it from 7 minus 4 minus 2 minus 1, their n should be 0 and their k is also 0, which means all values are filled. Okay. So what we will check, if n is equal to 0 and k is also 0, then you have to do something. Okay. Else, let me just write, if n is less than 0 or k is less than 0, then just return from here. You don't have to do anything. Okay. So if both are equal, then you have to insert it in your list. So list dot add sublist. Okay, and we just do return. Okay, so there is a problem at this 13 line. The problem is if you just do list dot add sublist, so what you are doing it every time you are inserting add the sublist and every time you are removing it. Okay, so if you insert into the list, like it will insert it reference, list reference. So every time when you update or delete it, it will basically, it will not have any element that will represent that particular valid sublist. So what we will do, we'll create a new array list of that type, because in list we are storing a reference. If we store the value, then it's different, but here it's a reference. Okay, so I think we have covered all the cases. Let's run it. Okay, let's see. Okay, so we are getting a wrong answer, and why I show you this wrong answer, there is a reason. Okay, so what is the reason? You can see like one is at that, like all are possibly valid output, but they are having a one thing wrong, like each number is used at most once, which we are not following. As you can see, 5 plus 1 is also 7, but 1 is repeating here. Similarly, if you can see for 5 1 1 2 3 2, all are 7, but the same digit is repeated. So what we need to do, we need to pass one more thing here. Okay, so we'll pass start, basically from where you have to start. Okay, so it's like we will take a start. So at every time you don't have to start from 1, you have to start from you should be start from start, and let's say you will take one integer at a time. So next time you can't again like pass here, you don't have to pass start. Okay, you have to pass here I plus 1, so the same element will not come again. Okay, so now let's run it. This time I think it will be, yeah, so this giving the correct output. Let's submit it. Okay, cool. Our code is submitted. The time complexity is, you can say it's a order of, like we are doing for loop, and inside that we are calling a recursion function. So you can say it's a n square, but it's just a 9 of loop. Okay, so we only have I 1 to 9, so it's a order of n, 9 into n you can say, and it's on an average it's a order of n. So yeah, hope you like it. Thank you for watching video, and do join the Telegram group if you have any doubt and any concern. Thank you.